In this example, we have a lot of stipulations that need to be met to draw the graph of g of x, which is x cubed minus 6x squared plus 9x. So we are going to use all this information to draw a picture of what this graph looks like, but instead of being a rough sketch, it should be pretty close because we have a lot of information here. So first of all, we have our end behavior as x goes to negative infinity. So remember, x axis runs left to right. So as x goes to negative infinity, that's going to be to the left, and as x goes to the positive infinity, that's out to the right. So just keep that in mind. Our end behavior as x goes to negative infinity is going down to negative infinity. So our left arrow should be going down as we go out, and as x goes to positive infinity, that means we're going to go out to the right as opposed to the left. It's going to have a y value going up to positive infinity. So our end behavior is going to be down to the left and up to the right. So our end behavior is down, up. Our asymptotes, there are none. There's no horizontal asymptote and there is no vertical asymptote. Remember, horizontal asymptotes are those limits at infinity. Here we don't have any limit at as x goes to negative infinity or positive infinity. It's going to go down without bound to the left and up without bound to the right. And then vertical asymptotes are what make you divide by 0. And nothing's going to make us divide by 0 because we don't have a rational function. We don't have a fraction for a function to start with. So then we're given increasing and decreasing. I'm going to make this into a sign chart because already this is a lot of information, and drawing sign charts helps me become a little bit less overwhelmed by all of this. So remember, if we are switching increasing at 1 and 3 and decreasing 1 and 3, that's our critical numbers. We can only switch from increasing to decreasing at a critical number. So I'm going to go off to the side here and make a sign chart with f prime. So we're switching at 1 and at 3 based on those numbers. So it's increasing from negative infinity to 1. So we're going to start off increasing, and then from 3 to infinity. So another increasing over here. And it's decreasing from 1 to 3. So it's negative here. So to just sketch this, I am increasing, I have a critical number, I'm decreasing, critical number, and then increasing again. So there's a rough sketch of what the graph is going to look like already. So from this, of course, because we switched from increasing to decreasing, we are going to get a relative max at 1, and then decreasing and increasing, that's going to give us a relative min at 3. And we're actually given these full points here, so we don't have to plug in and find those y values. The next part says the relative max is at 1, 4, and the relative min is at 3, 0. So let's go ahead and at least plot those points. So we have a maximum at 1, 4. So I'm going to put the point 1, 4 in here. And then at the point 3, 0. So there's my 3, 0 for the relative min. I always like to start by plotting points. Before we draw the general shape, I'm going to make a sign chart out of the next piece of information. I'm given the concavity and inflection points. So I'm going to make a sign chart out of the second derivative. And it should match the shape of that first derivative because it is modeling the same function. So it's concave up from 2 to infinity and concave down from negative infinity to 2. So it looks like our inflection point is at 2. Would be our possible inflection point, but I can already see it is changing concavity. So concave up from 2 to infinity, that's this interval over here, and concave down from negative infinity to 2. So we have our inflection point. It's going to switch from down to up, and our inflection point is where it's kind of between the two concavities, not really part of concave down and not quite part of concave up yet. And we're even given the y value of our inflection point. It's at 2, 2. So now we're just going to sketch what this curve could look like. Remember, we're going to stick with our end behavior. It's going to go down to the left, up to the right. We want to have it match both sign charts. So it should go increasing to decreasing to increasing, and then concavity should follow so that it's concave down to concave up. So I'm just going to start filling in here. I might just use this sign chart from the first derivative. I want to remember that I'm increasing. At first, I could plot some extra points in here that would make the graph even more accurate. So I could plug in any x into this equation and see what the y would be. So I could plot it. Maybe I'll just plot at least one point just to show you. So see if I wanted to find the y value at 0, for instance. I already know the y value at 1 is 4, 2 is 2 and 3 is 0, just from knowing the max, min, and inflection points. But let's say I want to know the y value at 0. I'd plug in 0 to this function and see what the y value is. 0 cubed minus 6 times 0 squared plus 9 times 0 is just going to give me 0. So I could definitely keep going. I could plug in -1 to this function and +4 and 5 and just keep plugging in and finding some y values, and my sketch would only get more and more accurate. But I'm good with just those few points there. So I want to remember that I'm increasing to start. So I'm going to draw something increasing. And then it's decreasing between 1 and 3. And then it's increasing after 3. I can continue this off here. So there's a sketch of what this could look like. Again, it would be more accurate if I plot more points, but this matches everything that we were given. It is increasing, decreasing, and then increasing. So the first derivative looks good. I am matching my end behavior. The end behavior was supposed to be down, up. So it is going down and up, so that looks good. And then lastly, my concavity, it is concave down. It looks part of an upside down U, and then it switches to be a right side up U, so it switches to be concave up. So I'm matching all of my different stipulations as well as going through the points that I was supposed to. So there's a pretty accurate sketch of the graph. And again, I'd just pick more points to plot if I wanted it to be even more accurate.